Yeah. Listen, don't talk. Okay, so we stop and graph the last time round. Okay, for part 1, most importantly, think about you try to remember the graph. Don't remember, try to plot a few points and we use the points to help you withdraw the graph. So the last time round, we stop at question 1.1. I just want to check all of this filled in. Okay, for all I filled in. Okay, so I go to, remember we talked a bit about how the relationship between x power 5 and negative x power 5? About x power 5 and x minus 1 power 5. So in the sense that if you look at part 1, this, right, the two graphs, right, they're actually a reflection. They're actually a reflection about the y-axis. Okay, they're actually a reflection about the y-axis. And part 2, so if you look at part 1, the two graphs are here, x power 5 and x power negative 5. Part 2 here, x power 5 and x minus 1 power 5. You notice, right, the graph, this is x power 5, this is x minus 1 power 5. You notice how this graph here, x minus 1, right? The graph, you see the black and the green, right? The graph shifts to the right. The graph shifts to the right. So, if in general, if you have fx, Cheryl, yes, bigger. So I need some space. For fx, say fx minus a. Okay, this one is actually translate y equals to fx a units in the positive x direction. Okay, so assume that of course a is more than 0. Okay, man? So this is called translation. This is senior high, you must know. Okay? So what about x power 5 to negative x power 5? You realize that if I go from fx to f of negative x, example here, where I do x power 5. Remember I did this, right? Then I wrote all this one, negative x power 5. Okay. This is actually a reflection about the y-axis. Reflect y equals to fx about the y-axis. Okay, just some trend for you to see. So you notice that if I minus a, it's actually positive. Right? Because now you see if I minus a, I shift right because now I need a bigger value of x to get back the same y value. So this is example like your question 1.1, part 2.1. This is like question 1.1, part 1. Okay. So if you look at this, power 4 and x plus 1, you notice that x power 4 is here. X power 4 is here. It's a quadratic graph. Then x. This one is wrong. This one is supposed to be a plus. This one is supposed to be a minus. That's what answer is. Okay, please cancel this and put a minus sign. There's a mistake. Okay, put the x plus 1. Put the x plus 1. Okay, x plus 1, if you did x plus 1, right? Move backwards, right? Yes, it will move backwards. Okay, so this graph is wrong. Let me see if I can erase it. Cannot erase. Please don't copy this. Don't copy this. Okay? The graph will, yes, the graph will shift. Translate 1 unit to the left. Let me use a blue one to show you what translate. Okay, and the turning point will be negative 1, 0. Y equals to x plus 1 over 4. Okay, So if you take fx, if you do fx plus a, you see in this case, I rub out the x, I put in x half. So when I'm doing this, right, okay, you got fx is x power 4, and you are writing this, right, fx plus 1. Okay, fx plus 1. This is x power 4. You are saying that this is x plus 1 power 4. You rub out the x and you put in x plus 1. Remember, this is the animated. If this is your fx, you want to do x plus 1, then this, remember, you are replacing the x. This is the x that comes out. Put x, replace x with x plus 1. Okay, ma'am? So you only touch the x. Okay, you don't touch anything else. Oh, so this will become translate y equals to fx, a units in the negative x direction. So for x, right, it's a bit counterintuitive. When you minus, right, it actually goes to the right. Because to counter, you need a bigger x value. When you plus, it actually goes to the left. Because I now need a smaller x value. Okay? So take note that this one, example, question 1.1 part 2. Okay? So let's look at the next one here. Okay, so I believe you can write down some reflection. Here, this is a translate. You are basically do a translation of 1 unit in the positive x direction. Right? So now that you all are high class, we don't use the word shift here, shift there. We don't use the word make big, make small. We use the word translate. Translate 1 unit in which direction? Okay? These are actually A-level questions already. Yeah? Translate 1 unit positive x direction. These are keywords. Okay? So this is a topic next year in H2 math. Okay, H1 math type part not to a big extent. Okay, for those who are have their own thoughts about what to take. So here to here, you basically translate 1 unit in the negative x direction. Negative x direction. Because x to x plus 1, what am I changing is I'm changing this x to x plus 1. This is the one I'm changing. Okay, this is the one I'm changing. Okay, ma? So you see x replaced with x plus 1, I actually translate 1 unit negative. I replace with plus 1, I go negative. Okay, so x is counterintuitive. Okay? Anyone? Yeah.
For question 1.1, like B, right? Like the fx to f negative x is reflect about y-axis. So this works for like ai, but then for like bi, right? The x about 4 is not like fit like that one.
Oh, bi,
Yeah.
this one, huh?
Yeah.
Oh, yes. Okay.
So then like what is it?
Oh, okay. Thank you. So clever. Okay, so this one is reflect about y-axis, right? So we can see that what I've done is I replace x with negative x off. And in this case here, I replace x with x minus 1. And for part 2, I'm replacing x with x plus 1 off. So if you notice, right, for B part 2, from here, okay, I set you a different idea. Okay, can I say that from here to here, y equals to x power 4 versus okay, y2 equals to negative x power 4. Right? What I'm replacing is I'm replacing y with negative 1. I'm replacing y with negative 1. Is that okay for you? Okay, so what do you think that will give me? Now I show you the graph. One is x power 4, right? Okay, wait, the graph is actually there. This is x power 4. This is x power 4, the one in black. This is negative x power 4. Compare the gray and yellow. How are they related? Reflect, very good, reflect. Okay, so reflect about the x-axis. Okay, this one basically is a reflection. So reflect y equals to fx about the x-axis. So in general, it's the same. If I'm going from here to here, this is A part 2, this is B part 1, B part 1, B part 1. If I retreat fx to f y equals to fx, y equals to negative fx. Okay? And I'm replacing y with negative y. So this will give me a reflect about the
yeah, so for number 3 is for odd powers, right? And then for number 4 is even powers, right?
Yes, that's one way to look at it. But not only odd power. So for example, this one, right, it can work even if I'm doing something like this. So let's say if my fx, right, for example, is not x. Not x, huh? Okay, not x. Not x will look like that. Okay, so now if I were to draw f of negative x, what will I get? Ln of x, right? Negative x will be ln of
Negative x.
no, negative x. Is it okay? So you notice that if it's ln x, right, I can only define for x to be positive. Whereas for this, you can only define for x to be negative. Because if x is positive, then this side is negative. So this one, it looks like that. There are also reflection about the y-axis. So my answer is it did not restrict to odd powers alone. It did not restrict to odd powers alone. So we can think bigger. Just think about replacing x with negative x. Okay? Don't worry, this one I will talk about it later. This is just to, even if you don't copy all this is just for info for now. It's actually in part 2, part 3, and part 1. Okay? Okay, so we look at x power n, where it's an odd integer, negative odd, example negative 1 or negative 3. Right? And x power 2, x power negative 2, x power negative 4. It looks like this. Okay, remember, when you have x power negative 2, it's the same as 1 over x squared. So the values remain, the y values remain positive. Okay? On the graph, there will be asymptotes. So when you are sketching this graph, do take note, you need to write down this, okay, y equals to 0 and x equals to 0. These are your asymptotes. Okay, you help me take note of this, you need to write this down. Okay? For for curve sketching, make sure that you label the equation of the asymptotes. The turning points, stationary points, as well as the intercepts. Okay? So please make sure that you label x and y, These are asymptotes. What are asymptotes? Asymptotes are lines that the curve tends towards, but they do not touch. They tend towards, but they do not touch. So help me to include all these on your graph. It's missing from the diagram, but when you draw, it should be there. Okay, it should be there. The asymptote should be there. Okay. For this graph, there are no stationary points, so no need. There are no intercepts as well, but there are asymptotes. Okay, you need to write them down. So both graphs, the asymptotes are the x and y axis. Okay, which is the y axis is x equals 0. X-axis is y equals to 0. Okay. So if you look at the thinking time portion, what's the relationship between y equals to x and 1 over x, or y equals to x squared and 1 over x squared? You can see that in a way, because they are reciprocal, they are like inversely related. They are like inversely proportional. Okay, if one goes up, this one will go down. The bigger my x squared, the smaller 1 over x squared is. Right? It's like the bigger my denominator, the smaller my value. So they are what we call reciprocal function. If one is increasing, the other will be decreasing, and vice versa. If one is increasing, the other will decrease, vice versa. Okay? So if you look at how x squared behaves, okay, so this is 1 over x squared. If you look at x squared, right? So for example, x squared looks like this. Just observe when I'm very close to 0, right? I'm looking from this direction. If my x is, 1, 0, 0, 0, 0. If my x is super small, 1 over a small number is super big. 1 divided by 0.01 squared. That's almost 100,000. But if my x is super big, 1 over x squared will become super small or big? Small. Okay, cannot super small. Okay, so quick one, I want to ask you, if x is big, if x goes to infinity, you can see that y goes to x squared goes to infinity. Then 1 over x squared will go towards 0. Because 1 divided by big number becomes very, very, very small. Imagine you have x 1000, 1 over 1000 is very, very small. Okay, 1 over 1000 is very, very small. Okay? Okay, I'll just pause here. I'll wait to copy. X 1.2. Okay, can you do the same now? 1.2, can you take some time to draw? Can you take some time to draw? Okay. Don't take too long, don't take too long. Y. Okay, you only need to draw the graph the same speed as me, otherwise you have no time to do during the test. Okay? So please try to do. This is x power. Okay, so you see how the graph, it must be tending towards that. Okay? As you see, as the graph comes close to the axis, the space between the curve and the axis and the asymptote must be closer and closer. This graph here is for y equals to x power -5. Now I draw this graph. Okay. Look at the green line. The green line is what I think Hongsun was talking about just now. Why is there a new asymptote? Because the graph shifts up. The new graph shifts up. Okay? The graph also shifts up from the bottom. This is y equals to x power negative 5 plus 1. Okay, but don't just write y1, y2, y3 because it's not clear. Make sure you write 1 in the equation. Okay? Make sure you write 1 in the equation.
Teacher, my actually hits 1.
Sorry?
Like the graph will end up at 1.
Oh, it will not touch 1. It will not touch 1. Okay? Wait.
That's what's the graph.
It will not touch 1.
Yeah, it becomes a 1 value after you.
I show you. So you see okay, it's an asymptote approximately. So like y equals to 1 or you see zoom further you see they will not touch. Okay, zoom further. Will they ever touch? Look at the green and purple. They will never touch. They will never touch. Okay, but from the naked eye, you need to zoom the again. What solidifies or what entrenches your thoughts is that first of all, x power negative 5 will never be 0. Correct? Right. So because of that, x power negative 5 plus 1 will also be never be 1. X power negative 5 is the same as 1 over x power 1. Can this be a value 0? Can this a value be 0? Cannot, cannot. Yeah. So when you study a graph, it's like knowing your friend. You know what your friend likes to eat, you know what you like to do when you go to certain places like the far west and the far east, right? The far north and far south. So here, remember, they will never touch the 1. Okay, they will never touch the 1. In the graph, the answer scheme is a bit wrong. So those who download the teacher solution, make sure you put a star there, you write down there, don't copy teacher solution. Okay. So just write down here, teacher solution is wrong. Okay. So for A part 1, I wrote down the answer. A part 2, sorry, is over here. In translate 1, you need the positive x direction. So next one, those who are at part 2, are you all ready?
Then at 1 is changed to positive 1 direction. So the asymptote form is not 1 or 2.
Yeah.
But then you're the one yeah, that's why I got
This one is
encouraging what we call a gladiator.
this one, okay. You all see, okay, x power is above the x-axis because all the y values are positive. Now, but if I minus 1, you notice, right? If I minus 1, what will happen is the graph translates 1 unit down. Okay? Translate 1 unit down. Okay? So you notice that part question, item number 6 question, 1.2b part 2, right? If you go from y equals to fx to y equals to fx minus 1, similarly you translate y equals to fx 1 unit
it's not the same. Not when you
in
times
the
y, right?
negative y direction. Okay, ma? Hello? So when you translate 1 unit in the negative y direction, okay, does the x coordinate change? It doesn't change. Okay, it's also what we call invariant. It's also what we call invariant. Alright? This is what we call invariant is doesn't change. what you see is that you can see originally that the asymptote. The asymptote is being shifted downwards. Y equals to negative 1. Okay, ma? So do take note. Yeah. Y equals to x power n, where n is a rational number. Now the first day we went through this on Monday, we sort of talked about this a bit. If n is a proper fraction, so you are taking your terms to a power less than 1, it sort of slows down. Right? But if the power is more than 1, it speeds up. It's like more than 1, it goes very fast. The gradient is going exponential. If it's negative, then it's going down. So in the sense that if you look at these two, right, they are like reciprocal of each other. Okay? So imagine if you have x to the power of 2 over 3 versus 1 over x to the power of 2 over 3, which is x to the power of negative 2 over 3. This graph is going upwards, then this graph is going downwards. Right? Because in the sense they are like reciprocal. Okay, they're reciprocal. Yeah, they're reciprocal. Cheryl, are you taking photo of this one? So the most okay, so okay. So one of the things you notice that when you use decimals to draw x power half and x power 1/3, when the x power half is only defined for x more than equals to 2. Okay, the reason because if you try to take x power half, it's like square roots. X power half is similar to square root x. Can we square root negative number? Cannot. Okay, anything with so-called an even number is like if I put x power 7 over 2, example, you are doing, let's say it's x power 4, maybe 3 out of 4. It's cube root of x power 4. Okay, beside, if it's a cube root, this can be a negative, but x power 4 is also positive. Okay, but you look at this. Yeah.
Then you have 4th power root to x power 3.
Okay, oh sorry, this way. 4 power 3. Okay, so you can see that if I put power 3, then inside here, by right it can be negative. Or if I just put 5, even better. Okay, so 1/3, x power 1/3 can be defined for all real values of x. Both graph pass through 0, 0 and 1, 1. Okay, so what I need to do now, help me take your decimals. You help me sketch y equals to x power 1/2, y equals to x power 1/3. Help me sketch these 4 graphs. Okay, iPad if possible. Don't use 4, this is 4. Okay, one just share with your friends. Just to go through the observation. Okay, so maybe everyone just whip out your decimals and then take a look. And take out decimals and take a look. Are you all taking out your decimals? power 1/3, you realize that this graph is not seen on the left because you cannot square root a negative number. But you cannot square root a negative number. So let's observe. I think you all saw this just now, right? You draw this, right? This is to the power of 1. Here, compared to this, right? But right. I think you can find it on your table. Okay, so you notice that, okay, compare the red and the black, x power 1/3 can be seen on the left hand side. Okay, because you can cube root a negative number, but you cannot square root a negative number. Okay, so x power half on the left, you don't see anything. Okay, the way to remember is that in power half, when the power is less than 1, it slows the value down. Right? Because I'm taking a square root 2 like that. Okay? And also, here you can see that it pauses at 1. Between 1, okay, x power half is smaller. Up to more than 1, x power half will be bigger. Okay, when it's more than 1, half to the square root 2 make it smaller. Okay. Just for a note. Okay, can you go to question 1.3? 1.3. Can we look at 1.3 and 1.4? Okay, just try it out. Give you about 10 minutes, then we go through 10 minutes. Ready? See the recording? Recording already. Okay. So we look at 1.3. Okay. I know it's a lot of graphs. I know it's a lot of graphs. There will be some marks allocated to it. Okay, so like I said, try to memorize. If the power is less than 1, then the graph will be climbing slowly. So just take note of this graph here. If the power is less than 1, it will climb very slowly. Okay, even if I put a scalar multiple on the side, okay, it will still be a slow graph. It will come up with this shape. Okay, so here, when you observe this, right? Okay, how do I solve 2x 1/6? Shall I do it? Okay, so 5x power half. If you find that it's very difficult, you can see a solution. That is one way. Another way is, okay, the way you teach it, you just change this. Okay, 1/6. 5x power half. I power 6 both sides. So that I make the power a whole number. Okay, I make the power a whole number. So this will be 2 power 6, that is 64. 1/6 times 6, that's x power 1. 5 to the power of 6 is, what's 5 power 6? 15825. 15625. 15625. Then x power half is x cubed. So if I cannot solve the first one, I solve the second one. 10. Right? It's quite good, right? It's good, right? So then after that, 15625 x cubed. Just like solving all equations, I take one side 0. Right? I see that solving equation can use factorization, factorize up. Factorize of x. 15625 x squared minus 64 equals 0. Okay? X can be 0, minus 0 product rule. X can be 0. Or here, 15625 x squared minus 64 can be 0. 15625 x squared can be equals to 64. Divide 15625 on the right. Then basically it's plus minus a over 125. Okay, plus minus a over 125. So that is for part 1. Okay, yes.
Can we jump from the first blue line to the solution by like touching the calculator?
From here to here,
The first blue line.
the first blue line
Yeah.
is
Then just get the solution.
okay, do you have 0?
Yeah.
Okay, I thought I got this one. So, first, okay. Okay. Yes. So this is question 1.3 part 1. Oh, sorry. No square. Yeah, sorry, no square. So, yeah, here to here I already square. So far, okay? Better now? Okay. Stay in here. I know this chapter is very boring. It's the most boring chapter that I ever taught this year. But okay. Now, then the second one. So solution gives you intercept. You realize that the first graph, part 1, right? You were solving this to be this, right? And you notice that there were, when you equate the two equations, right, you have 2 points of intersection, which is 0 and 0.064. Okay, so there are 2 answers, one here. These are the 2 answers. Okay, and after that, do put down the y value as well. Now, what is difficult is probably a lot of you didn't realize that they actually cross at 1, 1. Not cross 1. They cross intersect somewhere here. Okay, that's because you must remember for a certain value, right? Your cube root, the lower the power, right? It can be higher at the start. Then they will cross. Yes. Why is that? Why do I need to write the 1, 5 and 1, 2? Is because for the question, they indicate you draw up to x equal to 1. The domain is fixed. So we cannot draw more than 1. So if you see this one, children, the domain is fixed. You cannot draw more than 1. Okay? Next one. Yeah, so you make sure you stop at this point. Okay, that's a simple stop. Okay, question 1.4. On the same diagram, sketch the graph of these two. So 2 over 3, you can see it's again a slow slope graph, right? If I minus 1, translate 1 unit downwards. Okay, negative x plus 1, again, translating downwards. Okay, so all you need to do is just, if you do not know, is it correct? Correct. Yeah, correct. So from here, because at first, right, okay, how I do is like that. Okay, so from y equals to x to the power of 3 over 2, the graph goes this way, right? Then you draw y equals to x plus 1 to the power of 3 over 2. The graph goes something like that. Negative 1. Then if you draw y, it shifts 1 unit, negative x plus 1 to the power of 3 over 2. The graph is someone say. Okay, but they only want us to draw x more than 0, right? So I erase this part. For those who are wondering how to get the graph, I say again, from x power 3 over 2, you know it goes like this. X plus 1, it translates 1 unit to the left. Here to here,